So we're gonna just briefly. So this study sheet or cheat sheet guideline is really just that. It's a guideline. So if you open it up, find the probability, because today we're going to focus on probability. Tomorrow, vehicle finance, and then trigonometry. That's how I'm going to roll. So I'll give you a little bit of time to work on your by yourselves today. And so I would strongly encourage you, bring your booklets, bring your tests, bring all that so you can prepare. Okay. Okay, here, so we have probability. There's chance / probability. We have theoretical. That's what I call, right, TP later on, versus experimental probability. And you remember what I said? Theoretical is what should happen. Experimental is what actually did happen. Experimental probability, the importance of sample size, because it could be that these two should match over time, especially when you're playing like games, like dice, cards, you name it. After a large sample size, they should get close to each other. But if the sample size is too small, then obviously it won't. I will tell you this though, the only time they will not be the same is when you do a survey, like who you want to vote for, all of that. That is actually on its own, right? There's no theory. Like in theory, if there's 4 candidates, then 1 out of 4 will be selected. But really, it has much more to do with a survey result. Prediction, watch this. Prediction is the probability of that happening times the larger sample size. Okay. We use the theoretical probability to make a prediction. Very important. Odds. You have to know how to convert between odds and probability. So favorable would be on the left side, and on the other side you take the total minus favorable. And so I will just I will write something here. The reason I left some blanks is for brainstorming. So I don't really need to necessarily fill this in for every topic, but here it is. Let's go odds to probability. That's going to be our first entry under probability, right? And you should have this on your study sheet. Okay. So let's say odds of rain would be 3 to 5. Okay. The odds of rain would be 3 to 5. The probability of rain would be 3 over, what do you put in the denominator? Not 5, 8. It's 3 plus 5, okay? Your first instinct is going to just be like 3 over 5, but that's not true. It's 3 over 8, really. That's probability. So if you want to go from odds to that, this is the emphasis on the total. Right? A probability needs total number of events. So when you see odds of rain like this, what is this really saying? This is how many times it would rain, and this is how many times it would not rain or sunny, right? That's what odds do. They compare something happening to something not happening. I mean, by the way, the other days could be cloudy, right? Whatever, but it's just not going to rain. Okay. So that's how you go from odds to probability. I'll box this in. And then we have probability to odds. Let's write that down too while we're at it. So if you need to go from probability to odds, probability of red, let's say, Let's say they're telling you, hey, the probability of drawing a red marble is 13/27, let's say. So you should understand when you read that, I'm talking probability. Pink just doesn't work very well, does it? It's very bad. Try this here. Is that better? Okay. Maybe let's try one more thing. Quentin, do you mind closing the blinds? Or maybe Zero. Can you close? No, the other one behind you. Yeah, just roll down. There you go. Thank you, thank you. Is that better? Okay. So probability of red, we want to go to odds. It's saying, hey, what are the odds of red in favor of red? That's basically what odds would have to tell you. Is it in favor or is it against? Okay. But if it's odds in favor of red, we would go 13 and then on the other side, 27. And a lot of students would leave it like that. And there's something wrong with it. You cannot have a total ever in odds. So you got to go minus, take the 13 away from the total. So this would be 13 to 14. This would be the odds right there. And I remember in your notes, no total. Okay. Okay, just for now, I'll be right back. Go to page 8 in the yellow booklet and try to do some of those questions already. Okay. Page 8 in the yellow. And I'll be right back. Okay. I'm going to just add a few more things on this pink sheet. Sorry for the back and forth. But basically this point right here, right, is emphasized with these two boxes. You got to remember your expected value. And when you get your answer, you can score partial marks by just knowing this fact right here. If you get a positive, it doesn't matter if it's a big number or a small number. You're expecting a gain, so it's a good idea to play that game. If your answer is 0, breaking even, it either way is fine. Negative, you're expecting a loss. It would not be a good idea to put a bid in or whatever. Also remember that if probability of winning is 1/200, then probability of losing is 199 to 200, right? Like it's just, you got to remember they always add up to 1 or 100%. Also, you need to understand the difference between independent and dependent events. So if there's no replacement or the total changes, you would consider them dependent events. And here's my quick little example that I made up. So let's say you have 3 red, write this down, 4 white, and 5 yellow marbles. Okay. What if I asked you state the probability of drawing a white marble? By the way, this always will say randomly. So don't let that throw you off. It has to be random or else probability doesn't work. Probability as a fraction, you just need your total first, right? 3 and 4, like that's 7 and 5 is 12. And in this case, you have 4 whites. That's it. Please don't reduce a fraction because then I have to mark it wrong if you do it wrong. Okay, so all you do is if you want to, 4 divided by 12. If they ask to state this as a decimal, you go up to 4 decimals there. If they ask you to state it as a percentage, we just multiply that by 100 and state it like that. If it doesn't say anything, stop right here. 4 over 12, done. If it asks for a decimal, obviously you need to do that extra step, percent an extra step. Okay. B, odds in favor of drawing a yellow. What if the question says, hey, give me the odds in favor of yellow? In favor tells you that yellow will be on the left, and then you go total minus yellow on the other side. So in this case, you have 5 yellows. You go 12 minus 5, right, which is 5 to 7. These are the odds in favor of yellow. What do you do if it's odds against yellow? What would you do? You just flip it. If it's against yellow, the yellow should be across the fence away from you, and the rest is on this side. So just watch for that wording because it tells you where the favorable outcome is. Last one. And then we go over to our booklet, okay? If first marble is white, not replaced, that should say something to you. Not replaced, sorry. The first one is white and it's not replaced. And this is it. This is the last example on this. If they ask you for probability of drawing a red, you go to the top and you want to focus on the total first. A marble has not been replaced, so this actually goes down to 11, right? And then you look at your reds, and the fact that the first one was a white marble doesn't affect the number of reds you have, so that's just 3 out of 11. But if I asked you for the probability of drawing another white, your total still goes down by 1 for sure because the marble has not been replaced. And you started with 4 whites, now you have 3 whites. So how did we do this? We went 4 minus 1 to get that, and we went 12 minus 1 to get that. And so you have your 3 out of 11 as well. So they're actually the same now because that marble was taken out of the set and not replaced. So the not replacing is very important. And that's what we call a dependent event. Okay, dependent event. Okay. All right. Now grab your books. Go to page 8. And today, I know this has been a while. You just want to try to go through these questions. So I'll give you, I'm basically going to make sure I have half an hour for me to go through this. But for now, I'm going to give you some time, maybe 20 minutes or so, for you to do this. If you get stuck, maybe move on for now and then come back. But I will give you some hints, okay? So if you grab this book and you go to the probability section, this one only has 1 mark associated with it, this whole page. So there's gonna be very little work involved, like in terms of steps to get to your final answer. If you keep flipping, right, there's this one, this has a 2 mark. So this whole page is worth 2 marks. So that's gonna be a little bit more. There's also then 10 is worth 3 marks. So you know that there's going to be more involved when it comes to answering that. If you don't have your expected value, because you're going to need to find the expected value, your formula sheet actually has that formula on it if you don't have it with you right now. And I have some extra formula sheets right here that are yellow if you need it. So don't just sit there, try as much as you can right now, okay? 20 minutes. All right. So under probability, right, it says that Sonia won a prize in the contest. All of the prizes are listed below. Calculate the probability. Where's my highlighter? Right, so they want the probability, not the odds, as a percent that she won the t-shirt. Okay, I'll just make a note here that there's 25 items total, because I'm going to need that for my probability. And remember, probability is always the event over your total. That is key. That is a dead giveaway that it's probability. So probability of t-shirt, winning a t-shirt would be, there are 12 t-shirts out of 25. But we need to state it as a percent. So we've got to multiply that by 100 because of that, okay? So you just go 12 divided by 25, multiply that by 100. It happens to be exactly 48%. So no decimals, but if there had been, make sure you include 2 decimals, all right? So that'll be answering the question fully, right? This is box in your final answer to make sure that that's what you're referring to. What if it had said this, odds of winning a t-shirt? What if the question had said, hey, what are the odds of winning the t-shirt? Then it changes things slightly. So there are 12 t-shirts, and on the other side you would take the 25 total and subtract the 12 that are already on the left side, right? So that'd be 12 to 13. Those would be the odds of winning a t-shirt. What about if it said odds, and this is going to happen, right? Odds against winning a t-shirt. Odds against winning a t-shirt, you would take the 13 up front and the 12, right? And that's your t-shirts are there. The favorable outcomes for a t-shirt would be on the other side of the odds. Okay. Next page. Hope you're following. Okay. Question 8. Circle the letter that best completes the statement below. The number that does not represent a probability is, this is a decimal, it could have been. This is also a decimal, but it's not valid because, right, probability cannot exceed 1 or 100%. Okay, that's why this doesn't work, because it's bigger than 100%. So this one is good, this one is good. So the one that does not represent is letter B. Okay. Question 9. The weather forecast has the 2 dates stated there. Probability of raining on June 17th is 30%. June 18th, it's the odds of rain. It's 3 to 8. Yeah. So the probability here is 3 over 11. because you add it up, right? 3 and 8 is 11, which ends up being 27.27%. The best thing if you want to compare odds and probabilities, turn them both into probability. Okay? So explain which day Micah should choose if she hopes to avoid the rain. She should choose June 18th, comma, since the probability of rain is only 27.27%. Okay, versus 30. You can say that versus 30%, just to conclude your statement, right? So you've made reference to your work, and now you're saying that, stating explicitly. The one that is going to cost, unfortunately, this one costs a lot of you marks. And leaving this one blank, you don't want to go there, because if the test is worth 30, you miss 3 marks, that's 10% right there, right? You lose 10% just because you're leaving this blank. So this is what the formula for expected value is. The probability of winning, right, times you have to take the prize minus the cost. That is what we call gain, right? And then you have to go minus probability of losing, right, which is just the cost. Go ahead. And if there are more prizes to be won, then this part keeps on happening, but they would have to give you more than one probability. Okay. In this case, the probability of winning is 0.35. The prize in this case is 12,500. You subtract the 1,600 from it. This would give you the gain. Just do this in steps. Don't do it all in one shot. Probability of losing, you just get it from here, right? These two should add up to 1. So if you go 1 minus 0.35, you get the 0.65 there. And the cost of playing is $1,600. Do not put a negative in there. This is already taking care of that. Okay? And let's clean it up now. So 0.35 times 10,900 minus, I will just write this down one more time. You get, if you multiply these two, you get 3,815 minus 1,040. And that gives you a total of $2,775. Expected value is positive, therefore gain expected. It's a good idea to play. If they had asked that. In this case, they're not asking you that, so it's just make sure you have a $ in your final answer so you don't lose units there. So in this case, you would have gotten 1 mark for this part, 1 mark for this part, and then 1 more mark for the correct final answer once you clean it up, right? So it's easy to get some partial marks there for that. Next page. Page 11, or question 11, I should say. Page 12. Pay close attention to this one. A survey company, there's a survey, right? Asks a random sample of 300 people to identify their favorite TV program. And there they are, right? The breakdown. It says calculate how many people, right, would would be expected to identify program D if 5,000 people were surveyed. Okay, and this is making a prediction. Okay, so you're making a prediction. You take the probability and you multiply it by the larger sample. I don't know if you remember the question where we had like the student council, right? Like people, they did a survey and there were different candidates, right? And then so now you're supposed to make a prediction on a larger sample. What's the probability of people choosing program D? You go over here, it's 112 out of the 300 people asked or said they would choose program D. And you multiply it by the larger sample, which is 5,000. Right, this is your larger sample. Probability of choosing program D, where did I get that from? I got that from 112, and the 300 was actually given at the beginning. If they didn't, you would have just added all of this up to get the 300. And when you multiply that, it's the same as always, 112 times 5,000 divided by 300. So that's 1,866.67. Can't have that. So you say that's going to be approximately 1,867 people would choose, you would expect to choose program D. Okay, so this is my final answer, circle it. And so that's a prediction type. So you have to get a probability from the smaller sample and then multiply that by the larger sample. Anything that I want to add? Nope, that's good. Let's keep going. Question 12. This one I will put at the top. This one is experimental probability versus theoretical probability. That's what's at question. This is what they're trying to test you here. Each year, a market gardener randomly grows either peas, beans, carrots, or onions. The table below indicates which vegetables have been grown in the last 10 years. State the experimental probability, there it is. That's based on what actually happened, right? That the gardener will grow beans in 2020. Right? So you go and you have to say, well, let's go back and check how often did it happen, right? There's beans there, beans there, beans and beans, right? So that occurred 4 times in the last beans grown 4 times in 10 years. Right? So the experimental probability here would be 4 out of 10. Just leave it like that, don't do anything to it. Okay? And now it's asking the theoretical probability that the gardener will grow carrots in 2020. Okay? What would you say that would be? Any brave volunteer here? Yeah. Say that again. 2? Not quite. How many options do you have as a farmer? How many options were we given at the beginning? 4, right? Let's go back up here. There are 4 options. So in theory, out of 4, how many can you pick each year? You can pick 1 out of the 4 every year. So in this case, right, where did that 4 come from? Onions, peas, beans, carrots. Right? And this one is just, in this case, you want carrots, and so you only have 1 out of 4 if that's what you want. If it had says, what's the theoretical probability of growing beans or carrots? Beans or carrots, then there would have been 2 out of 4, or 50% chance. Okay, we can do this, right? It's not a big deal here. We are fairly confident that we're not going to mess that one up, right? So I'm just giving you the option there. Any one of those 3 ways of answering would have been fine. Okay, next page. Page 13 or question 13. Let's see how, you know what? There's only really, it's either right or wrong here. So if you haven't done this question, I encourage you to not just leave it blank, but I must tell you that it's either 1 mark or 0 marks. There's nothing in between here. So let's read it carefully. The odds, we know that they're odds, but anyways, odds against, I'm going to highlight that. Randomly selecting a country song from a playlist are, there's that, the odds stated there. So what does it mean if it's odds against a country song? Which one of these 2 would be country song? The left or the right? The right, because it's saying odds against this happening. So country is here. Right, this is country because it's against. And this is therefore not country. Okay. So state the probability, not the odds, right, as a fraction of Nico not selecting a country song. So probability of country, wait, I'm not done yet. What does this mean? Not country. Do you remember that? You go grab not country, which is the 345. And in the denominator, you're going to be tempted to just write down the 105 or the 345, but you got to add them both together to get your total. So that's 345 over 450. Okay, very important. So if this question could have easily asked you for, this is just an aside, the probability of picking a country song, you should still be able to answer that because the 105 represents our country songs and the total stays the same, right? Because you would still have to add them. This is just an aside. This is not what the question is asking, but and these 2 add up to 100% if you were to add them, right? Oh, I just wanted, I didn't check, but we're good because they're asking us to state it as a fraction, so we're done. Because if it had been percentage or whatever, we would have had to add a step. Almost done. Oh, we are done. Now it's vehicle finance. We are done. I'm just going to say this. I am doing a little bit up front here, but it's ultimately in your hands, right? How much or how little you review. My hope is that you finish, right, the year putting everything into it, not just settling with a score. If you have the green booklet, the green one is June 2015. I gave that out before the break. I have a couple minutes. I'm just going to try this one here. Because this is dependent versus independent events. This is the last question I'm doing today, and then we'll wait for the bell. You have to wait a little longer, right? Because we're grade 12s. This is on page 7. Okay, if you have it, great. Bring your test, your old tests, everything with in the next few days. So if you don't have it, just pay attention for now, and then you can fill it in later. There are 12 red, 28 blue marbles put in a box. Okay. And so this is 40 total. I'm making note of that. State the probability of randomly selecting a red marble. Super straightforward question, right? It doesn't say as a decimal, as a percent, so just 12 out of 40, that's it. But now this is the kicker. This is the one that when we need to go from odds to probability or vice versa, that's when I have students struggle. I'm going to try to leave this up here. But state the odds against a red marble. Before you answer, folks, can you do this for yourself? If it's odds against red, then red should be on this side. And this is not red. Okay, that's the focus here. So I would start with what it's being focused on, the reds. Where are the reds? So there'll be 12 here and 28 there. Or 40 minus 12, which is still that, okay? And so I'm just going to leave it there, and I will show you a few resources that I will make available to you. I will show you where you can find everything.